Welcome to the last high school research colloquium this semester. Today, we're honored to have Professor Adriane Randolph from Kennesaw State University, Georgia. And she's directing BrainLab at that university, and she's a professor of information systems. To save time, I'm not sure I'm going to say too much. I'll just say that she is going to talk about brain-computer interfaces as a new direction in human-computer interaction.
Yes, thank you. Hi, everyone. Again, Adriane Randolph, and I am coming from Kennesaw State University, which is about 20 minutes north of Atlanta, Georgia in the US. So we are the second largest, sometimes the third largest university in the state of Georgia at about 43,000 students, which is quite significant that we've seen this growth over the last even decade. So when I started 16 years ago, we were at about 10,000 students, and now this force within Georgia. And it's exciting also that we're at a research 2 level institution where I saw this newer guard of research focused faculty coming into the university as one of those members with still a student focus for our faculty and our environment. And it was a place within the College of Business that said, publish where you need to. This is really interesting stuff that you're doing, this brain-computer interface work, which is very much outside of the box of information systems. And so I met Jacek about 10 years ago through the neuroinformation systems community and our annual retreat that we have in now Vienna. So if you think the sound of music, this is what we experience each summer. And so excited also to see you again this day, doctoral student of Professor Gvizda. So it's nice to have this connection. I mean, I look out here and Dr. Huff, we also connected some years ago. I was saying, I think in my mind, I'm much younger than I actually am. So the experiences that I'm trying to connect on, I realize I have to shift maybe about 10, 15 years, but that's okay. This is what is part of the youth of it's through our eyes and this freeze framing. So I also welcome those online because I'm excited to see Dr. Brown, who was an undergrad student at Kennesaw State University doing work in the BrainLab in terms of connection to neuromarketing, and we'll talk about some of those ties, and now has her PhD and has gone on. So that's quite heartwarming. Thank you, Dr. Brown, for showing today. I have to see where I'm looking for the 360 camera. All right, so this is kind of this interdisciplinary, all-encompassing. What do you do when you think about, put your thinking cap on? What do you picture when somebody says, put your thinking cap on? And this is literally something that can help you control computers and understand your thoughts. Most of us may not be thinking of something that's like this Michael Phelps swim cap kind of thing, but we're literally collecting brain waves from surface electrodes. So sadly, I'm not drilling open heads in my lab, although this is an aspiration. So, when this track doesn't work out, that might be something I go back and pursue. And I would joke that we moved to a larger facility on the edge of campus because people were tired of the screams coming from the lab, but that's not the case. We're using surface electrodes to gain information about participants. And that could be people who are living locked into their bodies, and we'll talk about that in a moment, or people who are able-bodied, being able to understand more about what you're experiencing. So BrainLab, where does it come from? Talk about its ties to neuroinformation systems, and then some of the tools that are commonly used and some examples coming out of the BrainLab. All right, once upon a time, I was a converted IT consultant and came back for my PhD in computer information systems at Georgia State University. And Dr. Melody Moore Jackson was doing brain-computer interfaces. What was that? I mean, she was part of one of the first teams doing implanted electrodes to tie directly to those neurons coming with our brains firing for information and being able to harness that for real world applications. So out of a clinical setting to say, how do we control our environment? How do we communicate using these brainwaves, these thoughts? And so that's the origins, is to help individuals who are living locked into their bodies. And we say that from the standpoint they are completely paralyzed, they're unable to speak, but cognitively intact. And so those are our assumptions there. And we can extend this technology to more neurodiverse applications, but our presumption and expertise is around this neurotypical presentation. So, and I put that in quotes because what is a normal brain? But this is what our assumptions are. And so someone is not able to then voluntarily control their bodies, but still wants to communicate, control their environment, have a proactive engagement with what's going on around them and not being asked for their preferences. That then translates to the BrainLab at Kennesaw State University, where I am in a business college. So that setting in itself means we have extended applications for this technology, still helping people who are living locked in. So we're going out into the community to help patients, especially in home use. But we're also understanding how organizations and other individuals can use this technology. So it may be for training and cognitive load. It may be for understanding your secure or unsecure behaviors within organizations. And how do we get more complete information about you and your experiences, things that you might not be able to consciously articulate, but are driving your behaviors. And that is how we can get to changes in behavior. So the things that we're using in the BrainLab, EEG, so recording surface brain waves from electrodes, and that's using wet gel to connect to these electrodes. We're not using necessarily dry electrode systems, and I can talk more about the nuances between dry and wet electrodes. Essentially, it means we can get a better connection, better resolution on the data, and have more accommodation for if there is movement, for example, for someone who is able-bodied, that movement factor, that EMG, the muscular artifact, is much louder than these really small waves coming from our brains through layers of bone and tissue to get to the surface, right? The other things we're looking at are eye tracking, what's gaining your attention. Are we able to verify that you say you're engaged with the thing you're being told to engage with? Overlapping with what our study is calling for. Facial analysis of emotion, so the points of your face as you're smiling or furrowing your brow to triangulate that emotion, because we can also get a degree of emotion from your brainwave as well. If we're looking at differentials between left and right hemispheres, I have a naming convention, left for like. So if the left part of your hemisphere is lighting up more than your right hemisphere, it is a positive approach to that thing, so left like. If it's the right side, then it's considered more of a negative approach. And we're also looking at the sweatiness factor, so skin conductance response. And that is your galvanic skin response, your lie detector is what we most commonly refer to. And so we can learn to control these things. I mean, that's what the government doesn't want us to talk about, right? We can train our own biometric responses, but if we put it all together, there's little that we can cheat on all angles. And that's why we want to triangulate our data. The last bit I highlight is functional near infrared, FNIR, and I don't have a picture there for it, but it's essentially blood flow in the brain. So if you think about, if you are thinking of language, this part of your brain associated with language production called Broca's, you are having an increase in blood literally to that part of the brain. It's a hemoneural response. And if you are thinking of nonsensical sounds, you don't need blood in that area. So we can control the blood flowing to that part at will. And just in that binary response, we can overlay yes and no, for example, for control. Now, neuroinformation systems is relatively newer within information systems and information sciences. It's a nice term to really correlate to the use of these neuroscience-based tools and integration of neuroscience into technology use. So when we're looking at IT behavior, our interactions, most commonly we're using our traditional means of talk aloud or survey or observation. And those are reliable, but we can get additional information that's under the surface by using these biometric neurophysiological tools. And so that's the idea with neuroinformation systems, to integrate those neuroscience-based tools to gain a more complete understanding of someone's experience. We can also look at it for direct integration. So in the case of brain-computer interfaces, we are directly incorporating neuroscience principles for control of systems and for feedback about your experience into the system. The Neuroinformation Systems Retreat, a NeuroIS retreat, we are back in person. So every summer, as I mentioned, this lovely experience in Vienna now, that we have a more intimate group, just over 100 folks that are attending. And it spans information systems, cognitive neuroscience, all coming together around these novel ways of looking at neuroscience tools and answering interesting questions. And part of the organizing committee that you'll see, and you may see, you can pick out, yes. Back here. So a longtime attendee as well. And we try to not intersect with other related conferences. So there's a European conference on information systems and an international brain-computer interface meeting also taking place adjacent, but we want to be able to have those minds come together without interruption. So if you're interested, we will be back the week of May 30th in Vienna, and the call is out. So March 1st is the deadline for papers. So the idea is it's single track. This is a very developmental group, so don't think combative, think that we are trying to educate and bring everyone along around these different tools and grow the community. So I can take testimonials from folks in the room. So what are we doing? If you think of a typical experience, if I'm looking at reading brain waves and eye tracking simultaneously, for example, in this case, the person wearing eye tracking glasses versus an eye tracker maybe along the bottom of the screen, for example, to just track where the placement of the eyes or pupil dilation. Well, in this case, it is a biosemi system that's wired to a bioamplifier. So this is the device that is cranking up that microvolt signal so that we can hear it, essentially. And then an A to D converter, so analog to digital converter for the analog signals coming off of our brain into a form, those ones and zeros that the computer needs to read and interpret and make use of the signal for control or understanding. And those different inputs I break out into direct and indirect. Direct, I consider directly from your brain. So that's the electroencephalography, EEG, and different components might be motor area where we're thinking of moving, actually moving, or watching someone move. You have fluctuations in this part of your brain. And so the significance there is if someone is paralyzed, they can think of movement and have control in that area of the brain. Now, there is a move it, use it or lose it phenomenon, which ties into neurorehabilitation. So we do want to get to people early on to help train and continue this so we're not having atrophy in that area. P300 is kind of this aha response, a novelty, where we can use this oddball response to pick out characters and letters for control or whatever else we want to overlay onto an interface for control in an environment. Alpha, these are continuous waves that are associated with attention. We can also see if you're falling asleep. It's really quite phenomenal if you think about just from the naked eye, we can watch these brain waves going across and see if we get bursts, these big bursts that, hey, I need you to tune back in. And we haven't incorporated that directly into the classroom because we tend to be pretty good about seeing that so far, but thinking about advanced ways that we're incorporating these tools into education or can for the future is interesting. These other ways of education are understanding engagement for your brain. Are you overloaded? Is the student pretending to be along with it, but just doesn't understand what's happening. And we can have that indication also from EEG. Indirect methods are things that we're controlling, such as that blood flow response. So functional near infrared, having that hemoneural response changing, sweatiness, so our arousal and relaxation levels also changing. They can change at will. The eye tracking, where we're getting our attention being drawn to, and the facial expression. I grayed out fMRI, that's functional magnetic resonance imaging. That's the big magnet, 3 to 4 times the pull of Earth. Think the big donut that you might go into to get better resolution of where things are happening in the brain. I'm not presently working using that technology. So you think about what are the types of questions that you're trying to answer. So EEG is a more time-based response. We can get some topographical indications of where things are happening using different software, but fMRI is more fine resolution about where things are happening. So it's kind of a when and where kind of question usually. So now, how do we incorporate this into the way we are engaged with technology and our future use? It could be through control, and this is not just for people who are living locked in to their bodies, but how are we able to control devices using these thoughts, these non-physical responses? But also, how do we change our experience according to our different states? So we can have a continuous feedback of emotional state, for example, to enhance our experience. So not only will we name this as brain-computer interfacing, but this might be also termed as neuroadaptive interfaces. When we talk about experience, you can control games or your avatar. So in this case, this is an example, I think, World of Warcraft, where you're ambulating through and you can morph your avatar according to your emotional state. You can drive a car. This is me in Pittsburgh. Not me driving the car with my neural response, but an indication that you can, and there are active projects to drive interfaces and wheelchairs with this neural input. Your prosthetics. So we have direct control of neuroprosthetics. A few years ago, the World Cup, the opening kick was from someone in an exoskeleton controlled with a brain-computer interface. So you might have missed it, but it was a really amazing example of how this technology is in use. Also, virtual reality. So as we talk about the metaverse and full immersion, well, we're also able to test out things and understand our physical interactions in real space versus virtual space, and how do they match up. We can do training, we can have further understanding, again, using these neuroadaptive technologies. Now, something I want to highlight, though, is that it's not a one size fits all thing. So we do general mappings around the brain and responses, but our experiences do matter. So some of the examples that we have in the BrainLab are looking at individual differences and how they impact our use and interpretation of brain responses. In the case of literacy and experience, what we're looking at here is the results of people who are experienced in sales versus not, and what their responses are when they were viewing the initial portions of a sales call. So for those who aren't salespeople, which we have a sales center, a national sales center at Kennesaw State, when you're first meeting a customer, shaking the hand, getting to know them, that's called your approach. And so you're trying to understand that person or their needs. Well, we can portion out these different segments of making that sales call. And when you have someone just watching that portion happening, so in this case, watching video of that happening between a customer and a salesperson, for someone who has no experience, they don't really know what they're watching. And so what we see evidenced is cognitive load. So the red being the highest level of activation, and the triangle is your nose. So you're kind of looking straight down on the brain. And the frontal part of the brain there is mostly associated with working memory and where that cognitive load may be evidenced. So they're watching going, I don't really know what I'm doing, what I'm watching. And you can see that in terms of an average over, in this case, 5 people watching. Now, experts in sales. So we're talking about people with 5-10 years more experience in that segment of industry or teaching sales. We don't have the same areas lighting up. In fact, the red is more on the left side of the brain, which is, if you remember me pointing out, that was language, that was listening. And by the way, when we talk to them, because we still talk to folks after we scan their brains, they said, I don't know, when I was listening to what they were saying, I don't know if I agreed with what was being talked about. Oh, there was a lot of focus on the conversation. And so interestingly, we see that focus in the brain happening and not the area most closely associated with cognitive load. Why that's interesting to me? Because that's neural efficiency. When people who are experts in something are judging something that they're expert in, they're using less parts of the brain. There's lower levels of activation because they've got that pathway burned in. This is system 1 and 2 thinking. This is Kahneman's Nobel paradigm about our fast and slow systems of thinking, and being able to see that play out here. And so how do we use this? Well, in our classrooms and our training, we can perhaps see when we can change a novice brain to an expert brain, because ultimately we're trying to create experts, right? And what are the triggers in that case? When we're talking about communication and control, one example I talked about was that motor area of the brain. And this is an example of someone thinking of opening and closing their hands versus being at rest to move the cursor up and down in the Y position. So it's going across the screen at a constant rate to hit the target at the top. This is our former provost and president, Ken Harmon, who is just thinking of opening and closing his hands to hit the target at the top, and to hit the target at the bottom, just being at rest. But you notice you don't see any fidgeting of his shoulders or movement because he's not moving at all. This is completely neural responses. And yes, the computer screen may be showing the date of my video, but the principle of the paradigm still holds true, which we use when we talk about improving abilities. Because we can use this paradigm to improve your physical abilities. We, in this case, looked at testing through Wii tennis, because it's really hard to put you out on the court actually and control all of the factors when you're playing tennis. So we tried to control as much as we could, in this case, in a lab setting, where we said, play some rounds of Wii tennis, let's get a score, and then do brain training using that paradigm I just showed you previously, and see if we get any improvements. Well, statistically not significant, but practically significant. We did get improvements in their scores. And so they weren't playing Wii tennis during the week. There weren't other factors there. But it's neat to see the indications that we can get better at a physical activity from this brain training. And this ties into the neuroplasticity and the neurorehabilitation mentioned a moment ago as well, that we can see improvements. For some, it might take longer. We see this play out in stroke rehabilitation, but we can measure it and we can see it. When I talked about the P300 effect and how we can use that for communication, you're seeing an example here where a common paradigm is seeing a grid of characters on the screen, and you would focus on the character you want. And as everything is flashing at random, when your character lights up, you're going to have a response to it versus the other characters. And so by averaging, we're able to see that's the one we want to select, and then we move on. So the person can then proactively tell us which letter they're trying to select. In this case, this is Josh. You can see he almost did a perfect run on his first try. This is without fine-tuning the system. And that tends to be the case, especially for someone who is able-bodied with a stronger EEG signal for activation. So in this case, if you were to try it, you'd focus on the I for BCI. And when the row or column for I lights up, your brain will be sending that signal for intention that you want to select the I versus any of the other characters being selected. Now, we're also using this to improve a full system for people who are living locked in. If you think about a long-term care situation where someone is waiting to be asked how they feel, what do they need, they can use the system in concert with other sensor technologies to tell what's going on. So we're updating with more recent Internet of Things technologies to say, okay, if the patient is laying there and their feeding tube has slid out, we don't have to just lay in their fluid, which has happened. We've come to visit someone and go, hey, we've got this great technology. And wait, okay, they seem to be in distress. What's going on? Going through kind of this triage of questions to then literally lifting the sheet and realizing, oh, that we need quality of life care here before we get to this novel technology that we're talking about. So not having to wait for any of that to happen, being able to have the system trigger something to a caregiving team with all of the considerations for, having cell phone technology that they're using, protection of that data and of the patient, signals being shared across that institution, and even just motivation for that care provider, depending on, are we talking about a family member? Are we talking about perhaps someone who's not paid as much to do this job and what their motivations are? How do we incorporate that into a full system for better quality of life care? And then refine what that person is trying to communicate using a brain computer interface communication system. So we see here just kind of learning more about the system and signal processing. We have overlays even with improvements using machine learning and encoding, decoding pairs to understand that transfer of signal. Well, quality of life isn't just physical quality of life, it's also your social quality of life. And having some folks that we work with going, I have a social life and I don't want my mom integrated into those communications. Facebook, for example, has a plugin. We can overlay signals to be able to have someone share pictures or to share text. So the face brain interface is using that same P300 paradigm. So you recognize the grid paradigm for the interface, where we would randomize what's being highlighted to then select which feature we wanted to use, and then refine what we're trying to say, like, for example, with the chat, using, again, that overlay of P300 with the characters. It takes a little while. This is not instant. We're talking about averaging. We can speed it up if the person has had video game, first person shooter experience, for example, because their noticing gets a lot faster than someone who doesn't. But if you don't have another option, this is still more motivating. We tried to overlay it with Google Glass. So we do have a working prototype. Anybody remember Google Glass? Yeah. Well, for those that don't remember, Google Glass was using this heads-up display where you're able to access your smartphone technology, just like you're looking at a computer screen, but it's on your face. So it's a little computer. And for us, we were saying, we don't want to interrupt the environment for someone that we're visiting with literally a laptop and screens that we're trying to roll in with a big suitcase. Instead, we could be able to put it on this little used real estate on their face and be able to incorporate that into this communication system that was just mentioned. So instead of the tap feature for Google Glass or voice feature, which someone who is living locked in would not be able to access, we could do so through the brainwaves. And so we're using that P300 paradigm to be able to do that. Google Glass is still being used in focused segments. So within medicine, within manufacturing. So this is hands-free use of technology, augmented technology to understand picking parts or seeing diagrams of machine parts or the body, for example, when you need hands-off access. Just not the mainstream public right now. I think we'll see another iteration All right, so with that narrow glass that in face brain, so similar setup as before, without the eye tracking component. And so we have it running on a secondary machine right now, but being able to port that processing of EEG onto Google Glass would be the aims, because again, it's a small computer. Now, I'm particularly excited that within the last year, we've had this work evidenced in our top outlet within information systems. So we call it the basket of 8, and the Information Systems Journal has published around this context-aware communication for locked-in persons. I'm particularly proud because it has been a long time coming to get that work showcased within an outlet of such note. So fortunately, the human computer interaction community has long since been around this, but understanding how we can use technology, this is what we're about, using technology and understanding our interactions, and in this case, to incorporate folks into what we're all doing here for communication, but understanding that there are different modes that are more in sync with communication needs. So media synchronicity theory being the lens for examining that communication. We also use this technology to understand someone's experience, and in this case, looking at partnering with corporations, for example, which it doesn't have to be a corporation, but website experience, this shopping cart experience, things that might happen better in physical space, how do they translate online? So in this case, it's a grocery store saying, are folks having a similar positive experience when we present this deal for produce and they don't get to pick their apples directly, but have to do that through our shopping cart experience? Well, we can see one, are they having an overloaded experience? And it's not just waiting until the end to find out if it was good or bad, or to what degree, where we go, okay, so how was that? Or I saw your brow furrowing at some point, but can you describe that or have them talk aloud? In this case, time locking that experience to where and when that interface component was accessed. So was it clicking on the drop down? Was it making the calculations? Where and when? So that we can then change that point in time for that user. That's the beauty of this technology, is that we're able to get real-time syncing to when it happens for someone. So we can overlay, again, that EEG response also with facial. You may be able to see points of the face here. And that is, the smiling or furrowing of the brow, and having that, again, synced to the stimulus itself. When did that happen? So we can put all of those biometric responses together at one point in time. We use this technology also to understand when someone was interfacing with their inbox. And this is tied to phishing experiment. So with a PH phishing, where we're just going through our days, getting tons of emails. Some of them are emails you shouldn't be clicking on, right? But are we systematically training ourselves to be unsecure in our behaviors? Do we notice that these are emails that you shouldn't be clicking on? When you go to training, right? That's pretty, oh no, I'm not going to click on that email, that malicious email. That's right. That's from someone that seems suspicious. But when it's day to day, maybe it's late on Friday, does that still come across? So this is just the pilot portion of that I'm showing you, where if we looked at just one aspect of that neurophysiological data, in this case, eye tracking, we get a similar pattern. And this is across 2 individuals where the first participant is an IT specialist for our university. So this is the person that trains you on don't click on the emails. And the one here, the second person, that's an IT professional who consults, understands how technology works, and is doing strategic level implementations for companies. Okay, so conceptually, we understand there are these attempts that are coming into our inboxes, and this is what it would look like when I'm scanning my inbox for both of them. Okay, from that alone, not necessarily something novel between the two. And then you can kind of see as we capture, let's see, a full experience for someone, kind of where their cursor is, where they're looking on the screen. Like we can put it all together, even hearing their talk aloud. So when we talk about triangulating data, there's so much in that experience of just one or two people. It's much richer. And so it's not the same as saying, oh, we need 100 participants to make this be statistically significant. Think more in the realm of qualitative study in terms of richness of data from the individuals. So now though, compare that to the recordings of their brain waves during the same scanning of the inbox. And I'll just give you a quick orientation. Let's focus in on this, looking at it from the front or the back of the brain. Here is the front of the brain. And that is our judgment or trying to figure things out area. The yellow being the highest level of activation in this case, being evidenced. And do you remember my naming convention? L for like or positive and R right being more negative. So the negative being evidence for the first person. And this is in the front of their brain. Oh, I realized I think I swapped the two here. I'm sorry. So our first participant was the IT manager, and the second participant is our IT professional at the university. Okay, so the IT manager looking, trying to just scanning the inbox, is having a more frustrated experience. That did come across when we interviewed the person talking. This is Friday after the full work week, by the way. And he was interested in participating in the study, but just kind of, what do you have me doing here? Okay, I don't know. And so we have a little bit of that right, more evidenced there, that more frustration, and the frontal lobe where he's like, what is this that I'm doing? I'm thinking harder about what's in my inbox and should I click or not. The IT professional, it's not in the frontal lobe in terms of highest levels of activation. It's actually in the back of the brain that we're having the highest levels of activation. And the back of the brain is around visual engagement. This is the visual cortex. And this person said, oh, all I had to do was look at the inbox and I knew, oh, not clicking on that. Guess what? This is what we're seeing in terms of correlating what that person in their narrative is saying to what their brain is showing us. Okay. Now we also can extend this to that paradigm of how hard your brain is working. In this case, looking at chemistry models. I don't know, anybody remember chemistry? This might be personal confession time. Okay. How many loved chemistry? Hey, okay. You seem reluctant to admit that. I'll tell you what, chemistry almost took me out. I was an engineering major, and that first chemistry class made me say, what other engineering major does not require a second level of chemistry?
When I came to the high school, I saw there was a special scholarship, which was for information science students who had a background in chemistry.
Really? Ooh. See, indicating this is a particular path of difficulty, right? And it is in that there's not a rote way of how chemistry models are presented to students. And some are more complicated than others. So this study, I say, is my own reckoning with chemistry. So partnering with someone from across the university to look at different models, whether it was on paper, physical models, or models on the computer. And this classroom exercise that we simulated to see how hard are students working as they work through these different exercises. And we used eye tracking and EEG. So the eye tracking was actually most helpful to say, were you looking at the model? Were you using it in the way that was intended? And then EEG to measure cognitive load. So this is part of an NSF grant to understand cognitive load. And so this is through the eyes of one of the participants, and you hear her talking aloud from her experience.
Okay, so try to match like these groups of the colors on here. Let's see where the pocket might be.
Right, so it's an interactive in-class experience. And these models have magnets on them. So you can kind of even pinpoint where on the model the molecules she's looking at some point, it also helped improve. This instructor has produced these models with 3D printing at her institution and making a second version that had transparency on the models to help improve that. So there's so many layers to what we can gain from this full experience that we're looking at. But as far as the cognitive load goes, we could see, this order of activities really overwhelm students early on. Instead, if we change the order, it lowers their cognitive load. They're still engaged, but they're brought along in a better fashion. Because by the way, if you're overloaded, you make mistakes, you disengage. And we don't want that to happen. We don't want you to fall asleep, but we don't want you to be completely overwhelmed. All right, so there's many things going on in the BrainLab, and essentially we're using this technology in different ways, different partnerships. So you heard about sales, you hear about user experience, and about working with patient populations. So we absolutely span different disciplines and different areas. And the only requirement is, can you look at things in a proactive, novel way? So this is an array of mostly undergrads, some master's students, and one student in the middle is now at the University of Washington in her PhD program today. So just exciting to see folks go along from experience working in the lab to further graduate work or professional experience. And we just kind of say, yeah, are you ready for a new way to think?
Thank you so much.
My pleasure. So, any questions? And tell me your name.
Sorry. My name is Edgar Gomez. Edgar. I have to pronounce it in the American way. Edgar.
Oh, okay.
My mother put me as following Edgar Allan Poe, so she was in a dark side, I guess.
Yes.
Yeah. Okay, so thank you for your presentation. I think it was fantastic. And I'm sorry to start with a kind of like challenging question, I guess. So while you presented the framework as a positive one, for example, talking about how disabled bodies will be able to do things. Being a critical scholar, I cannot help but just think this is perfect for advertising, military, policing, etc., especially when combined with algorithmic recommendation, with machine learning models. And so, it's one step further into control. And so I was just wondering if you have a commentary about the ethical dimension about the work, which I think is very important.
Yes. So Edgar, I appreciate the question, because not only ethics from biasing and what's going in, and I'm going to try to harness my thoughts here because it's very much something that's, pun intended, been on my mind in terms of access to the work, first of all. So within the neuroscience community, there's long been that especially persons of color have not been part of the research. One, because of just a gatekeeping on the hardware and the technology being used. So when I show you an electrode cap and talk about there's gel that has to be inserted to connect the electrodes from your scalp to the electrodes. Well, so for you, sir, we get to use less resources. So if you don't see, Edgar has less hair on his head, but there are some that have more hair on their heads, and we have to access the scalp. So culturally, this can become a little bit more complicated, whether it's you're talking about locks and braids or wigs and weaves, and some that are using different hairstyles to have the choice to be able to participate in the study, to have their experiences incorporated, but also to understand how the hardware incorporates into gathering data. So that's on the one end of access and talking about what data, whose data is going into the collection and creation of models and things. The middle of it is my fully optimistic view of let's use our superpowers for good and being part of the questions that will help people and the access there. And I'm recognizing, yes, there could be some more nefarious uses, but we've got to have our voices there as well to shed light on that for all. The other parts of it still related are even the security implications. So most recently at the NeuroIS retreat, presenting to that community, we have EEG in itself being recorded from individuals. When I put through an IRB, there's no issues with that. We've been recording brain waves in psychology, et cetera, for ages. But what does the IRB ask you? Where is your data being stored? How is it being stored? Okay, EEG is de-identified, no problem. But is it really no problem? Because there's a lot more embedded in the EEG than we once could access. So as we talk about algorithms improving and being able to analyze the data there, I mean, we are talking about inherently the EEG is personalized to individuals. And we may not all appreciate and understand that. So there are actually additional protections that we need in place for that. To me, it's about education and awareness and having those conversations and having them openly. So I guess that's the best I can do is say.
Can I push a little
Yes,
further?
please. This is the conversation.
And that's the last bit of my question. Well, you say, let's use these powers for good. In the presentation, Metaverse, Uber, Nintendo, Facebook, Google, all of them were part of the
Evil core.
So no, I mean, I guess I'm just worried about most of these corporations already have enough power without scanning our brains. They know a lot about us just by, what the metadata that we say, the behavior. So if they connect the, behavioral change with brain scanning, I was just wondering, like, do we really want that? Even if your research is not in that direction, they can easily read your papers and say, you know what, there's something here.
That's right.
Let's just develop this or.
So what's going to stop that? This is an open conversation, I think, right?
Yeah.
If they want to use it, they will do it themselves. It's part of it.
Yes, but should we be helping them? I guess it's not about your work. It's just about a conversation that probably we all, in the university should have. And I'm not trying to.
No, beyond the university, we need to have.
Yeah.
So a version of this is around marketing. We go, oh, should marketers have this access to? Guess what? Marketers have been doing this for a while before we talk formally about brain scanning technologies. Or artificial intelligence. We're using a newer term, but we've been doing this concept for a long time. So that's where I go, I think it's more about maybe the focus of the conversation and how it's painted. But we need to understand the realities and not the myths of things. So, for example, we were talking about Neuralink in the car and Elon Musk. So to bring you into our conversation, right? Elon Musk has one of his many companies is implanting electrodes. And so far it's been focused on implanting electrodes to pigs. But the idea is that we will be the pigs soon. So humans being able to have these implanted electrodes. Why is that such an importance? Well, when I talk about reading brainwaves from the surface, that's an average of the activity from our brains. When you're implanting electrodes, you're getting to pinpoint where the firing is happening. And that's the difference, is that you're getting more fine resolution of where that communication is taking place in the brain, for finer control, for better prediction of what you're thinking to image resolution, for example, and hopefully a lot of really wonderful uses. Yeah, absolutely. There's gonna be some not so wonderful uses to come out of that. I'm not sure how to stop it. I just say this is part of our job to have these conversations and shed light on it, and hopefully keep access, right? So it's not just certain individuals that are controlling.
Thank you. I appreciate your answer.
Sure.
Yep.
Yes.
So my question also has a little bit of a dark side, but one of the slides you had here at the beginning about the salespeople example, where you compared the
Yes.
novice salespeople to the experienced salespeople, really interesting. Have you tried comparing? So the expert salesperson is someone who has gone through the narrowing funnel and succeeded at that. If you started with a bunch of novices and compared them all, and then saw who later on succeeded versus who later on failed, do you know, or would you speculate if there's any sort? It's a sort of nature versus nurture question, right? So are there innate differences from the starting points that predict the ending outcomes? You see, because this has a dark side too, right?
Sure.
Yes. Likely to succeed being a salesperson because we've measured you at the beginning.
Right.
You heard like the people who succeed were at the beginning, right? The people who failed, they look like this.
Right.
So you can see the dark side.
Yeah.
Absolutely. I mean, that's the parallel to that is
Technology and
I was going to say Amazon and bias and algorithms, right? Scanning resumes or what have you, or the video interviews.
PhD admission programs. If you have papers, you can get into the PhD. The purpose is to train them to write papers.
Oh, I see.
Yeah.
Yes.
I guess it's a question about the extent of plasticity versus innate differences in brain,
Right.
and how much that the training picks up on certain things and helps certain people succeed, but would never. Some
How
of
much
us,
does it affect?
I tried to do sales at one point in my distant past. I was terrible at it. Other people seem to be, naturally inclined toward things. And so I don't know whether this is anything you've looked at or whether you just want to
No, I think that's part of, I'll add that to the bucket for a longitudinal study, because we could, in terms of a classroom setting, look at the beginning of sales majors, and what does that look like for folks, and kind of class by class, seeing their performance and progression, and make some extrapolations to success, whether it's correlating it to grades, but there's additional placement, success in our sales competition, for example. So real life enactment of what they've learned. But what you're saying is, yes, we have to be cautious of what are we characterizing here, and what are we kind of attempting to, are we railroading a profile of person?
Is it tracking that goes on from kindergarten that says,
Right. So personal example of that tracking is, so I have my oldest is a 12-year-old young man in middle school, and he wanted to go into advanced content math. And so I'm talking with the assistant principal about, we'd like to go into AC math, and it doesn't really matter what math he's in, and just whatever, this is what the scores coming out of elementary school. So you're trying to tell me that I feel gaslighted, by the way. Like, you're trying to tell me that it doesn't matter what level of math he's in for future, like there's no tracking? That sounds like, like that doesn't sound all the way truthful here. So I understand that maybe you're trying to sell a kumbaya, like, everyone, just be good at what you're good at. I get that. But don't tell me that it doesn't matter, because it does in terms of future opportunities. So that's what we're talking about. Are we closing off opportunities for some individuals versus others because of this, these correlations and things that we've seen? Because it's correlations, by the way, right? And we have to be very careful that it's not causation, that it's not direct because we want to do that. We want to say, this is what we see, this is predicting this. There's so many other things happening, especially when we talk about these pesky humans that we're putting electrodes on and your experiences and all these other things that go into it. Right? So I'll add that to my caution bucket, but also something interesting that we could add into a longitudinal study. Thanks.
Wonderful talk, and it got me thinking, especially on a paper you did with people with motor disabilities. And it got me thinking about what are some more applications with these brain-computer interfaces for people with other types of disabilities. Especially when talking about self-driving vehicles, which is something I've studied beforehand about improving independence and mobility for people with disabilities, those who can't use conventional vehicles, and this type of application to help improve it. Because one of the issues is, what are the design aspects of it that's kind of discriminating against people with disabilities? Because they're building it almost the same way as if someone that could drive it would. Just you're no longer controlling it. But what are the interaction aspects of it that could be improved to make it more usable for people without sight, people with motor impairments? And then I'm also thinking on the other end, we talked about, this is more of my research areas like online learning, online engagement, there's communications facilitating through different mediums, people with usually screen readers, magnification, people with augmented or alternative communications. Like, what are some of these, what would you envision like kind of the biggest benefits really in this area in terms of accessibility?
Honestly, I think it's an area that's not been tapped into as much, to use these technologies to understand the full experience of someone who is not able-bodied and using technology. And we do this all the time in terms of, oh, you know, I've got this convenient population of folks to study, but we might have to be more purposeful in how we access folks that are also using this technology in other ways. And even with like talking with pharmaceutical companies, for example, and this personalized health experience, they're not using the neuroscience tools in the ways that I've just described. So they're using it for like understanding epilepsy, for example, activations in a clinical way, but not understanding, so is the person having a positive experience as they engage with your full care recommendations, and how is that for them? We can get other triangulated responses from these same neurophysiological responses. Just kind of thinking about it in a different way, application.
Agreed. And in some ways, when you think about it in that way, the brain-computer interface could be viewed as some form of assistive technology in that sense, which brings to another aspect, kind of dark side. I'm trying to theme here with the other kind of aspects of, if it's viewed in that light, then it becomes a highly probable commercial property, which becomes another area. Could you think about, for example, refreshable braille displays for people with vision impairments? They're great, but they're also very expensive. They're thousands of dollars. Certain mobility aids also can cost thousands of dollars. And so the fear is, if something like this was to be kind of commercialized in a sense to assist in certain activities, that's going to be the same issue, is how much they're going to charge for this and use it more as a means to get rich in aspects. But then that also creates greater inequity, because not everyone can afford even the existing technologies that are being used.
That's right. And they're not covered under certain things. I mean, when we talk about computers, how difficult it is for someone to get a laptop funded, you know, but it's part of communication, not just surfing the internet, you know, and having fun. So I think another part of that could be competing as technology improves, like the sensor technology improves, that we're not necessarily having to use these gold standard sets of electrodes and equipment, but we've learned more about perhaps what channel, what area of the brain that we can tap into with just one channel, for example. And so a less expensive device, maybe that's more in the commercial realm, could be effective for communication for some, or for monitoring in other cases. Then in those cases, it might bring the cost down. I don't know, I guess I'm thinking of.
In a way, yes. And then lastly, of course, ensuring that when they're designing these type of technologies, that there are input from those like people with disabilities involved. And that's
yeah,
also
that's
the
right.
biggest knock is we have technology that's supposed to support people with disabilities,
Yes.
but their input is not involved in the process, just as with these self-driving vehicles and other technology that we're using today.
Oh, because it's so inconvenient. Yeah, absolutely. Being very conscious, purposive about what other variations of that word? Purposeful, right? And including our true in-target population, which of course, the principle with assistive technology is if we build it for more, I mean, the people perhaps that was not intended for initially, they're going to benefit in the end, called the curb cut effect for folks not doing assistive technology work. You know, when you're walking along the sidewalk for those ambulating, the cutout in the sidewalk, so you can have your wheelchair go along, you can have your stroller go along, you can have your motorized scooter go along. Now, like all of these different things are benefiting from that. So thank you for bringing that to light. And hopefully future collaboration.
So I want to ask you also about challenges, but not going into the dark side. But all of these are, of course, very important. So what do you think is the biggest challenge to use these technologies in everyday life, in various contexts, in various possibly complex situations?
The biggest challenges to using brain-computer interface or neuroadaptive technologies.
Yeah, I mean, all of these that you mentioned, whichever you want to comment on.
I think one aspect is a social concern. And I think Google Glass gave us some evidence of this, where if we're looking at some novel technology and do we have understanding of it, that there's a level of fear. I mean, I think it's inherently embedded in our dark side conversation here, right? Well, and what does it do? What can it do? Is it going to be inputting things into me, or is it allowing me to express externally? How does it work? I mean, I think that understanding is going to be one particular barrier. I think there's aesthetics incorporated into this. So we have some advances, for example, in gaming communities or particular audiences that have different needs or thoughts about the aesthetics being incorporated. But for example, I have a colleague he staunchly refuses to participate in any study that I offer. As wildly supportive as he is verbally, otherwise, he does not want to get gel in his hair. Okay? I will not name this person, a favorite person, but not interested in messing up my fantastic hair. Like, okay, that's fair. That is your thing. So this is part of just different human concerns as we present the technology. Does it become less intrusive for others to see, to notice? Is it kind of a behind the ear, something that not everybody notices you're using, but I'm able to still control things neurologically? I mean, we have the C-grid behind the ear for EEG recordings now. So this convergence of sensor technologies and miniaturization and getting everybody to the table. I mean, fashion designers need to be part of this to make this something engaging and neat to use, not just scientists who that's not necessarily all of our forte. We've kind of relaunched our space at Kennesaw State, where I have a new collaborator in the suite, and he's a metaverse visualization person, but he's also an artist. So that's his other side. And the way the space has just changed and the way it looks, the paint, the experience when you walk in, it's not just, I was fine to just have my conference table to one side and my equipment over here, but full display walls. So you have this, what is this immersive thing as you explain about the brain and how you can be engaged? Wow, that's so different than just, let me hear my electrode caps and hear my things. So to have just different ways of thinking about it, come to the table to engage in that question about what are the challenges.
So do you think that these challenges that you described are more difficult to overcome than technical challenges? I mean,
So to me, the technical challenges, I think it's ongoing, iterative, where it could be, the signal processing and algorithms, like we are continuously in our parallel disciplines working on those things. There are improvements being made as we get better with our processing capabilities with the chips and hardware, like that's happening. So it's all converging, in my opinion, but there's still this holistic people that we want to use these systems conversation that needs to take place. And it can't just happen from the electrical engineers or the neuroscientists where we all have our certain angles to look at the problem, right?
I mean, it seems to me like some of the resistance to these kind of questions about the brain is because we have a relatively rudimentary understanding of how the brain actually works.
Sure.
Compared to, say, prosthetic hand or prosthetic leg, we have a pretty good sense mechanically of how a hand works. And so just say to somebody, we're gonna put a mechanical hand on you.
Right.
I'm sure there's barriers to that, but it's not quite the jump emotionally and psychically as saying,
Right.
we're gonna do something that's interacting with your brain that is how you view yourself in some way, but we also don't really know what's going on up there most of the time. So I don't know, there's a question, there's a comment. This difference in people's idea of intrusiveness and their uncertainty gap when you don't really know what's happening.
Yeah.
That seems more likely to be still fear because there's this great unknown inside the brain.
And continuously being uncovered again as the technology and imaging techniques improve. This notion of not just mapping of areas of the brain, but networks of activity in the brain, that's a newer concept, right? Within neuroscience, I think for systems folks, we're like, oh, that seems pretty logical. But from within the community to see it and then the evidence that we can see through the imaging support. And that's, you're right, it's just really the beginning, I think. I think it's exciting.
in terms of design, can I show something?
Sure. You want me to?
I don't think you need to do anything.
Okay.
I can share my screen. If you are okay with this. So just in terms of thinking about design, these are eye tracking glasses from a company in Berlin, Germany. And some of them are scheduled to be shipped in next year. Some of them are just concepts. So I am thinking this is just, I would even say, brilliant idea that they thought about different types of designs in this space for different types of applications. So some people are thinking and bringing designers into the table here.
So I love this example. It also ties into this neuroscience of habit and what we kind of just do day after day after day, that we need some other cue to do something different. And for marketers, I think they think it's about like a coupon, like an older school version would be, I'm gonna send you a coupon and you're going to buy this product, but will it make you buy that product long term? No, it's not, unless we change what's triggering you to get it. So my personal example might be peanut butter. I'm always gonna get Peter Pan peanut butter. Whenever I go in, Peter Pan peanut butter, that's what I get. And then because my mother introduces Jif to my son, and he goes, "Oh, I like the way that tastes." That's a different cue. So now I'm going to consciously go into the store and get Jif. That was a cue. That was something different. If I was left to my own devices, I would only get Peter Pan peanut butter. We do this in everything in our lives. I'm giving you this product example, but that's the secure, unsecure behaviors and clicking on links and how we're behaving. It is, what are we seeing as acceptable in society? What are we using for technology? To me, this is presenting different paradigms for, hey, when I'm going to the gaming convention, I'm gonna pick a different solution. When I'm going into my work environment, I'm gonna pick a different solution. But it's normalizing, these are solutions that we can incorporate.
Joystick, I don't know if there's someone asking on the chat. Oh, I've seen like.
No, this is, I already handled, this is old.
Oh, okay.
So thank you for noticing this. Yeah.
Yeah. I mean, just an anecdote, with some colleagues in Melbourne, we did some experiments with eye tracking. And one of the things that we noticed is that when our female colleague wore the glasses and we went into the city, she was looking at A, purses, B, shoes, and C, the chest of other women.
Okay.
But the first thing that we noticed when she actually put the headset, not the headset, but just the glasses, is that she constantly look at my bald head. And I just realized, oh wow, she made me become conscious about being bald. So yes, but no, thank you.
Your hair wasn't enough, make it conscious.
I mean, but I never thought like somebody will just look at me and constantly look at how bald my head is, and because I was actually tracking her side, I was able to see how constantly when she looked at me, the first thing that she did was go to my bald head, which it was truly sad in a way.
So I would, for the qualitative part, say, so did you debrief that with her?
We did, and she was like, well, of course, shoes and purses, but like she blushed when I told her, like, look at the data. Here's the data.
Did she know that she was doing that?
Well, I don't think she did. She did.
So I'll be. This is a fun organic conversation. I'm like, I think it could have just been the light shining off of your right?
Yeah, but I don't have an explanation. Yeah, for sure, I don't have an explanation. But I guess what I'm trying to say again, and I'm sorry, I haven't left the dark side. These are very cool and hip, but like, do we need more data inputs about our bodies or thinking or behavior to be sold to marketeers? Like, do we really want that?
There are positive uses of
Okay.
the data. So if we consider interactions with virtual reality or even using Zoom, often it's awkward because our camera is facing somewhere, we are looking somewhere else. And if we have this additional input from where our eye gaze is pointing, we could improve eye contact in remote meetings, virtual environments.
I will also touch on that a little bit further in terms of just the design of the glasses themselves, because the researcher that talked about, speaking more of an accessibility, people with disabilities, is the idea of social accessibility. So you design some assistive technology, but the way you design it, it would make you look like okay, they definitely have some sort of disability. Right. It's more pronounced. So the idea is, why not design this technology to be patchable or something that's more socially acceptable, so they're not so conscious of their own disability when they're in social settings.
So like, oh, that's cool. I want one of those.
And I also think that, like one of the answers could be like better policies. For example, the tech runs, I feel like the Wild West in specifically here. If we just go across the pond, because of the stringent policies, they cannot do so many of the things that is being done here. For example, my own dissertation research, which like tracks undergraduate students over a semester, I would have had to like cross many more hurdles if I were to do it in Europe, for example. And I think they are coming up with a new responsible AI and explainable AI policy, which will go into effect next year, that companies have to sort of disclose exactly how recommendations are being made. And there has to be like clear guidelines on what they can show and what they can do with people's data. So I think if that comes as a push from the government, maybe.
I personally don't think that's going to happen. Europe, the European have the most progressive policies about data, and I don't think the US will implement those anytime soon, to be honest.
Yeah, true. So sure, I mean, then like a short myopic answer to your question is, shall we go and do all the research in Europe then? Because there are better policies to put into play, like shall we?
I don't think it's about worry you. I mean, I think the conversation should be more than just this is fun and cool and will allow me to know more. Do we really want to kind of like have that approach to research without realizing that the potential harm of these developments, it's now very clear after years of Facebook and Google. So
Yeah.
But that's again my personal position about it.
No, it's interesting. I mean, I think you're talking about unintended consequences, some intended consequences, depending on who the collaborators are, and intention. I think there's also a warring of our own personal preferences and experiences in the research. So I tell my students, I am a late adopter of technology, personally. I do bring computer interface research, but as far as my own personal space, I don't have smart technology around me in terms of the Alexas and the Google Assistants. It's very annoying to my husband, who is an early adopter. Like, I will turn it off. I will move it away. And we have this competing. He told me, I was like, I don't like features. That's apparently how we're explaining this. I want the thing to do what it's supposed to do. So in a vehicle, I want to use my key to turn it on and drive my car. I like driving. I don't want the display to go out and not to be able to drive my car. I don't want so many sensors telling me that I'm driving badly when I have an excellent driving record, actually.
Exactly. And you don't want your insurance company to have access to that data and to play with that.
Right.
On the other hand, like, no, sorry. I read about this in the book by the author who did the facial emotion recognition, Rana El Kaloubi of Effectiva. So she was saying that one time, like she had a very bad sort of meeting, went out of her, like she was almost in tears, and she went into her car to drive. And she could have, like, in the mental state that she was in, she was lucky that she did not hit anyone. So do we want like self-aware systems during that time to sort of understand if the person is fit or ready to drive? Because that happens so many times.
No. What we want is for, companies and organizations to be more aware of their workers and their social health, like mental health.
Yeah.
I mean, if you're going to put money on one thing, I would personally put money on changing the organization rather than just put money on technologies that can understand when you're crying and prevent you from. But that's again me. I'm so sorry.
That's who we need to have as part of the system.
Yeah, it's like putting on a band-aid instead of solving the real problem.
And you're putting a band-aid on a thing that you did to yourself by putting another band-aid, and so it's kind of like
Right.
an iteration of that. we create a system like, Facebook, and then we will just create this other system, which is artificial intelligence to prevent these things. But then we will add another layer of technology rather than rethink, should we be doing this at all?
Glad you're in the world.
I'm becoming one of the last ones in
Well,
that.
no, I don't. Not. I hope not. Wow. Glad that we could invoke this conversation.
Mm.
I think we need to broaden it, certainly to our students. Just going out. Anything
Any
else?
other questions?
Was there anyone online for questions?
No, there were no online
Okay.
questions I was monitoring.
Thanks. Well, thank you
Right,
all
thank you very much.
online.